Hello everyone, welcome back. Now, in earlier video, we talked about the Peterson solution for two processes. Now we'll implement the same Peterson solution for critical section problem. But here, instead of two processes, we'll use threads. So Peterson thread. So we'll go with the same example where two processes were there. Okay, and they are trying to work out with the case. Let's include the files. I should include std.h. Now we are going to make use of pthread. So that's why pthread.h hash include std_bull.h. We will require that, correct? And then hash include std. So let us define the flag variables. Bull flag of 2. Initially, we'll declare it as false, false. Correct. And then integer turn. Now let us write the code for first professor. So code for thread 1, that is professor HV, or you can say KN, whatever. So let us write this code. Okay, now for this professor, we are going to, like, as he has to show the intent, correct? So we'll implement the same printing aspect. So let us first write the function for it. This would be void professor KN. This is our procedure name. This there would be, as we are talking about threads, so argument. Fine. So entry section first for him, flag of 0 equal to true, correct? Then he will set turn for the other professor. Now let us check for that flag, while flag of 1 and turn equal to 1. So if both the things map, correct, then only the chance would be for entering into critical section. So this was entry section. You can write here for understanding purposes. This is entry section, and this is critical section. Let us write critical section. Okay, now what is to be done in critical section? The printing should happen, correct? So professor KN star printing, correct? That is critical section. Bracket complete. Slash and double quotes. Done. Now we have to simulate printing. That's why we'll ask the thread to sleep for 2 minutes by 2 seconds. After 2 time minutes, Professor KN completed. Printing. So now he should leave the critical section. He should go towards exit part. Correct? So then lastly, the exit section. Exit section would be what? He should set flag for himself as 0. False. Correct? And we will say it should not return anything. Just communicate saying Professor KN finished. So same thing we have to write for Professor HV. So I will copy this code and repeat it for Professor HV. So we have to make particularly changes here. HV HV flag. Ultimately, we will change the parameters. So this would be for Professor HV, Professor HV, correct? Then for him, flag 1 equal to true, turn equal to 0, and you should check for the other thing, turn equal to 0. HV started, then HV completed, flag 1, correct? Now for him, flag 1 should be made false because earlier case we made it there. So this is second process, second thread code that we wrote for Professor HV. Now let us go back and write the thread-based program with main function. So we have to create two threads. So structure first, pthread underscore d, thread 1 and thread 2, correct? So let us create the pthreads. Create. Okay, what is to be done? So first thread, so thread 1, correct? Now we know pthread function. The the function name. So first thread should be Professor KV. So we wrote function name as, sorry, Professor KN. So let me go back and write here Professor KN. This is the process name or function name for thread. Same thing now. It is to be written for Professor HV. Just you have to change here to. Now once they are done, they are executing. So pthread join, correct? Or thread 1, thread 2, and then once done, return 0, and your main code is done, correct? Now if we let us understand what exactly this code means to us. So what we did here, we created two threads. Okay, first thread is for KN, second thread is for HV, correct? And we are having flag 0, flag 1, flag 0 for KN. Okay, so flag 0 means he wants to enter, correct, if it is true, and flag 1 means if flag 1 is true, then HV wants to enter, correct? So we are assuming the values appropriately. So further, like if you see, we are applying the waiting condition in the code, okay, by saying that first, like in the main code, we are calling the creating the threads, and then in respective procedures, what we are doing is for Professor say KN, we set flag 0 equal to true and turn equal to 1. So he's asking like whether Professor HV wants to print. So he's waiting till he communicates his intent. So if he doesn't communicate intent or he doesn't have any intent, then Professor KN can start printing by entering into critical section. Similarly, the king, like, then he makes his own value to false, which was set to true. Now here in this case, what he did was he made this and then appropriately flag 1 equal to true, false. That's how it will be addressed. Now, so depending upon the condition, so both professors are polite, but the turn variable breaks this tie and ensures only one enters at a time. So if you see, all three conditions would be satisfied here. Mutual exclusion, never both inside the critical section, which is ensured by the while condition. Correct. Progress, if one is free, the other can enter immediately, and bounded waiting also is there. No one waits forever. Turn ensures fairness. And this is not a fight, it's over politeness, correct? So both say you go first, but turn decides who actually gets to go. Right? So let me save this code and let us try rather compiling this. So GCC -m32 Peterson thread.cx. So if errors are, then we'll solve. So you can see now Professor Kane started, Kane completed. And now, like for example, if I increase the sleep parameter over here, sorry, so that we have to execute this. So I will set this sleep to say 10 for both the processes, so that we can check how exactly it is done. Correct. So let us save this. Correct. And let us go back. I have another terminal open here. Okay, I have closed it. So I will open that terminal so as to check it here. Correct. So we'll write here ps dash first A. Correct. So that we can see what is the PID for main the thread. Right. So let us check it. So let us write ps dash. Oh, so we haven't compiled it. So we have to compile the code. That's why the code finished early. So ps dash t dash p and our 27555. So you can see these threads are running there. Correct. Both the threads are running for it. Correct. And then ultimately everything worked out. So here PID, SPID that you see over here is the thing. Like you can see same thing which was implemented using now threads. What we saw the solution with respect to earlier processes. Now the same solution is implemented using what you can call it as the threads. Correct. So let me go back again. Let me compile it again and let me execute it. Let me check it here. Let me replace this code by 580. You can see three, one is done. So one thread completed. You can see the communication. Right. So what we'll do is we will add sleep for the main parent. Correct. So sleep say 5 so that we can see like now the resources freed. We'll see one by one like how exactly they are going out of the solution. So first of all, ps dash a, then 27605. Now you can see 3, 3, now 2 because Professor can completed. Now Professor H will finish. So you can see that only one is remaining. Now Professor the resources freed all of them. Correct. So this is how you can simulate this Peterson solution using threading. Thank you.